Hello everybody, welcome back to From Rhythm to Algorithm Part 32, Sizes and Sets. In this episode what we're going to do is continue our physics, math, linguistic arguments, but try to again derive physical reasons for the size of mathematical sets and bases. There's one physical basis, but there's different types of numbers, so we'll be talking about some of that. Oh! What's this? This is just titanium alloy, reinforced Kevlar, 757 military grade. I went up and picked up a loaf of bread today, and here in good old US of A, I didn't know to have a shootout with somebody, murk a couple ops, there's gonna be a foreign invasion or something. So I just forgot to change, so just don't worry about that. But clarity on expansion versus contraction physically, right? Expansion means more, means growth. These are just things from the last video that weren't clear to me when I watched the episode. Contraction, right? Expansion to range, contraction to basis. Division versus multiplication in terms of vibration, right? If you divide light, right, we've said, matter had to be created at some point. But matter is not still being created, right? It's the conservation of energy, the conservation of momentum, universally, right? We've talked about tension path for local systems, but universally, it's not creating more matter. So, division versus multiplication, right? Very beginning episodes, we talked about why you always use the forward-looking operator, right? Because time moves forward, blah, blah, blah. But it's not clear to me, physically to mathematically, does division pair to contraction? Like multiplication, I would say, compares to expansion, right? If I multiply, I spread my seed. I have a kid, but I spread my DNA, and then the kid goes and eats food and puts on mass from the environment. So, division versus multiplication, just fundamentally, is there a real physical difference? I think I might be talking myself into saying no. But again, there's fundamental stability of two. There's two ways to look at each operator. Again, I don't know. Addition versus subtraction, same type of argument. But in terms of discreteness, addition and subtraction, you're just adding one thing, subtracting another thing. Multiplication versus division, you're talking about matrices, is the picture I have. And then exponentiation versus natural logarithms. That's really where the boundaries of systems come into play physically. The inflation of the universe comes in physically. And exponentiation is clearly expansion, and natural logarithm clearly pairs to contraction physically. But we've been trying to get a handle on tension. Still don't know. If you said, what is tension generally as a physical concept? How does it apply into the mathematical structure? Don't know. But we can immediately define expansion is extension. Expansion, extension, 3 syllables. Consistent with our generality statements from last episodes, and then we can say, extension lengthens, and it does. Just a logical mathematical note, but not talking just about the structure of logarithms, right? To be clear, the Fibonacci sequence is 1 and some change. I don't even know what the ratio is. The base E that I said is 2.718 and change, and pi is obviously 3.141 and change. But again, these are all mathematical representations or specific examples of the dynamic limit. These are all geometric relationships. So I just want to be clear there. Now, logically talking through a logarithm. If you see this in math class, how is it presented? Typically, you're given the base. We've talked about there's one physical basis, vibration, but basis in mathematics is just a number. So you'll say, you're given base 2. What is the logarithm of 8? So y is, or f of x equals y. y is the dependent variable, x is the input, the independent variable. Y depends on x. But in this, you're only given like one variable. You're given the base and then you're asked the question, you know, how it's read. What is the logarithm of 8 given base 2? And that equals 3. So you're saying logically, given a base, what exponent am I going to use to get a given result? So logically, in formal mathematics, the structure of functions to logarithm is different to me. I don't know what to do past that, but that's a very clear difference to me. So that's why I just have up here basis, range, independent versus dependent variables. And again, I don't know if logarithm is pairing to, like I said, the boundary of a system. Why is there only one real input? You know, you're given a base, you're given the response or the y. So I was just talking through that logic. And now, getting back to what we said last time about this fundamental physical proof that I'm trying to put together. You know, we've talked about why 1 and 2 are not numbers, they're fundamentally stable, the universe progressed with fundamental properties, and time moves forward, we're not going to go back. So include 3, and then the infinity sign is 8 rotated from geometric linguistics. How many elements is that? 3, 4, 5, 6, 7. 5 elements. And I'm using the word elements, not sure why, as opposed to set, group, or category. I think it's more general. Element, yep, there's our syllability. But when I was doing my original derivations on the handwritten things I have to you, this was a very profound physical realization. It was like, again, 5 categories or complete groups of physical properties plus 1 mathematical operator differentiates into all of the dynamic limits we see in all of the different equations. So where do prime numbers come into play in this? Right? A prime number is indivisible. A prime number is non-factorable. Let me make sure my camera's still going. So we've discussed in rigorous biological and fundamental physical reasons as to why there's irreducibility. In prime numbers are the manifestations, the quintessential numbers of irreducibility, of the irreducibility theorems. So maybe we take the 5 elements of physical categorization and try to pair them to the first 5 prime numbers. And to be clear, 1 and 2, right? Known mathematics says 1 is not a number because it only has 1 divisor itself, but a prime number is defined as a number and the only 2 divisors are 1 and itself. So that's why 1's not prime today, but 2 is also not prime because it's not a number. I've proven that. So the first 5 prime numbers would be 3, 5, 7, 11, and 13. So if you had to say, we've talked about the historical reference to 12, I would say, like, again, why is 12 relevant? Because it's between 11 and 13, and it's like it's like the wrong. It's a composite number, but like I said, you can write composite numbers as matrices, as ordered pairs or arrays. You can't write prime numbers as matrices because the fundamental stability of 2. But, so I just have, again, the set of, I guess I'm not exactly sure what prime numbers does to this, or what I'm trying, but this is very clear to me now. So I just have a physical numeric system written as 0 to 8, and then with a 1/2 over it, just because, like, this is a complete numerical bounding of physics. But again, it's just a geometric result, can't talk through it logically much even right now. Infinitesimality. I don't think I've talked about this in a while, but remember, infinitesimality is if you take a sphere, right? We've talked about dimensions now, we're only working in 3 dimensions, known mathematics is in 2. But if you take a sphere and you put another 3-dimensional polygon in there, and then you take n to infinity, the vertices, the planes, the the sheets or the planes, you're going to have a decreasing volume as a function of n. So that is clearly what infinitesimality is geometrically, physically. It is the rate of volume decrease between the inscribed polygon and the sphere. So you add that to the irreducibility theorems. Again, I have to do more work, but this is where the integral, right? We've talked about integration, we've talked about iteration, doing something more and more and more. Integration logically is, tension as a concept into physical theory, but right, this irreducibility plus infinitesimality is 100% why you have the dx, the integrand, whatever the fuck this thing is called. But that is why it's logically as area under the curve, and the correct three-dimensional extension is inscribed volume with as a decreasing ratio, and such that 3 is greater than 2. Right? This is why Fermat's last theorem does not have solutions greater than 2. This is why, again, I've derived the Riemann hypothesis in complete generality 3 or 4 or 5 times in my life. This is why it all reduces back to the line 1/2. And again, still working on collatz in terms of the byproduct of the numeric of iteration. It will be a numeric statement from that. But now we take 7 colors, right? I'm still not clear on division, multiplication, exactly what that is physically, but 7 colors plus 3 primary colors plus iteration plus 3 note durations from my music videos, right? Quarter, half, and whole. Maybe I might have even written a song about that. But we can take this, and again, somehow... Well, what I was saying, my camera cut off, forgot to clear my memory card. But we can take this physical argument and say 1 syllable equals 1 beat. And the unit of a beat is momentum, right? If I pound my foot on the ground, right, you can clearly hear like a physical peak, a literal concentration of the rhythm, right? That's how when you're trying to dance and you're all awkward, you're like, oh, I can't synchronize, I can't time up. That's what's happening. But again, just developing the physical arguments for a fundamental physical proof, which is literally the highest level of proofing you can do. But just a couple other things. This can be some argument. We add the infinitesimality and the irreducibility arguments to general size completeness. And the infinitesimality, the ratio is never going to get to actually 0. Right? This is a physical reason as to why 0 does not exist. Is because there's always, as you zoom in, you're going to have a curved line and a straight line, and it's going to intersect at 2 different points, right? And this is exactly how you root a parabola. Woohoo! Go Riemann hypothesis! But, that's why Isaac Newton had to use conic sections. This is really the fundamental geometric reason. And, just a corollary proof thing. This is why parallel lines never exist. Or never intersect, is because they don't exist. Moving on, so that's the development for the fundamental physical proof. Now just reviewing basic linguistics, right? We've said infinite biological uniqueness, therefore infinite word definitions, right? Function makes words apply to different things. So in 4th grade, you'll hear a noun is a person, place, or a thing. And I have a question mark. Is a person a thing? Yes. Is a place a thing? Yes. So, those are redundant. A noun is a thing. Is a verb a thing? Yes. So, fundamental, logical, linguistical incompatibility stuff. What's going on here? What is the right definition of a noun? What is the right definition of a verb? And just have it vibe crossed out. I've talked over about that in email. Again, that just strikes me as a fundamental iteration, right? I to E, B goes from, space 3, right? There's 1, 2, 3, 4 spaces in our complete word. It goes from 4 to 3, but verbs vibrate. Nouns also vibrate. Vowels vibrate. Vowel, verb, noun, too. So again, I think we need a clarity on what is a noun, what is a verb, and I don't know. Syllability and opposites, just trying to connect linguistics and math in terms of matrix representations, right? We can write this is to that, what that is to this. D opposes re, the prefixes. X opposes question mark. What's the logical opposite prefix to suffix of X, right? Tension, extension, that's expansion more, but X is like negative, former, it used to be, my ex. So again, that's just an example. I mean, you can try to put matrices, like cross multiplication. This should have some implication of cross multiplication when you have two fractions and you're solving, some percentage. I don't know, just another number A over another number B. B times X equals A times 100, and then you divide. So, just very rudimentary, but I was thinking about matrix multiplication and cross multiplication. Why do we have different type of algorithms or steps to take for matrix multiplication as opposed to just multiplication? Should be a fundamental different thing. So again, like I said, this is we can solve a lot of open math problems. And you say, what the fuck's a noun or a verb? And I'm like, shit, Bill, I'm not too sure. Oh, what's that? Oh, sorry, I thought I was taking some shots, doing another math video, go to the grocery store, maybe get a massage. You just really never know here. But thanks for watching From Rhythm to Algorithm, part 32, sizes and sets.